Hello. Hi everybody, and welcome to the afternoon talk of the Cloud Village. So I'm just gonna do a simple introduction. For this talk, we will be introducing some core concepts of threat modeling for the cloud infrastructure and architecture. And we will also propose a approach to decompose the cloud architecture for threat modeling purpose. And at the end of it, we are also going to introduce some concepts like and a framework for risk management, like threats, and also the best bit of the talk that I like and my favorite part is Hanna is also going to provide a demonstration of how to use the AI tools to do threat modeling for cloud. Yeah, so that's the introduction. And okay, so let's have an introduction about ourselves. Hanna.
I'm here. Hello guys, my name is Hanna. I'm a lead security engineer. My main area of interest is cloud security, secure landing zone migration. I'm also an active Microsoft certified trainer. I do cloud security trainings online and offline. And this is my first DEF CON. I traveled here 10 hours from Amsterdam. Yeah, hope you enjoy.
Hi, this is also my first DEF CON, but I've been to besides Las Vegas. This is not my first time in Vegas. I love the city, my third time. But this is the first DEF CON, and also I've been speaking at the community stage yesterday. So this is my second talk to get through. So I am a senior security architect at EPAM. I'm also heading up the UK team. And Germany and Switzerland team are leading a group of architects and engineers. My specialism is in AppSec, CloudSec, Azure security. I spending the previous 7 years in cloud security, and I'm also speaking at a lot of conferences previously. For example, B-sides. I've been spoken at about 5 B-sides already. Yeah, but this is my first talk at DEF CON. I absolutely loved it, and I hope this is going to be a special and successful one. Yes, I can make a start. So I just want to provide an introduction about what is the current stage of the cloud threat modeling. If you are working on a cloud project or cloud native project, you're probably dealing with multiple tenant environment. That's like a norm. And services, functions, and containers and microservices, that's what we deploy in the cloud environment. So that's why we want to emphasize the fact that the traditional approach of simply drawing a line between different networks is not sufficient. And what we want to propose is to decompose that architecture into smaller block, to allow us to efficiently to threat model. So on my screen here, I kind of drawn up a conceptual architecture that I currently working on. Is a project that's building in the microservices environment, microservice framework in the cloud AWS environment, but I'm using Azure at the moment. As you can see that we have a lot of workloads, including APIs and services functions deploy within the compute area, and caching is quite common as well in this case to improve the performance of our application. And of course, you have mainframe. That is where the data are in the green zone, where it's basically sometimes it's on-prem hosting at the data center that is not even on the cloud. So basically, I want to talk about the idea of we have a different environment that we sometimes have to deal with the situation that we need to deal with cross-tenant issues and challenges. Just some stats for you to have a look at. They are quite obvious that a lot of our applications now are cloud native, and we deploy on the cloud native platforms like Azure, GCP, AWS, the main three. We have more. So the use cases for multi-tenancy, sometimes people probably going to ask, why do we use multi-tenancy that, when data are storing in different locations and we need to isolate? There are a lot of use cases. For example, if your company is providing a SaaS application, it has to be deployed in a multi-tenant architecture because all the customers, each customers are users all the customers are using the same application, but their data and configuration needs to be kept isolated and separate. We also have the API and gateways and shared infrastructure. That's also a good example of when something that needs to be shared between different tenants, and we need to keep them, we need to thread model them separately and in the different blocks. So I would like to introduce some challenges that are quite specific to the multi-cloud, multi-tenant microservice architecture. So things like sharing infrastructure across the tenants, introduce those risks. For example, when considering isolation, secure communication, identity management, some of that is probably the primary challenges. So first of all, we probably have seen a lot of workloads that are shifting around or dynamic. For example, auto-scaling pods, we use that all the time, and some shared resources such as clusters. Secondly, we have a service mesh that is quite common in this architecture, which adds a layer of abstractions to how services talk to each other. Things like MPLS, sometimes it makes it harder to fully model all the potential threats across the service-to-service communication paths. Propagating identities. So that's something we want to ensure per tenant access controls at every single services is sometimes it's tricky due to the shared API and federated identity systems, and of course APIs. Yeah, APIs. So depending on how your application. Just the previous slides, actually, I haven't finished. Depending on how your application is structured and so sometimes API can be service-to-service communication can be done with the centralized API gateway, and sometimes it's not. So threat modeling in this case is very important to help us to understand how we're going to threat model the cloud infrastructure depending on our requirements. So on this page, I don't need to explain too much about the process because some of our folks probably already familiarized with how threat modeling work. If you work in AppSec before, you probably already familiarized that. But here I want to focus on the decomposed system in sessions. So basically, we need to break down the systems into smaller, manageable components or subsystems. Sometimes it's depending on the trust boundaries. I will be talking about trust boundary in the next slides, and how to divide the trust boundaries, because sometimes it really depends on the factors and different situations. So trust boundary, it is a point in the architecture where the level of trust changes. So data across this boundary must be validated and authenticated. So what we propose here is that we need to adopt the zero trust principle. So every single data transferring from one boundary to another needs to be authenticated. It must be authenticated. So in the microservices model, services should not inherently trust each other. So sometimes we need to use frameworks like Spire for assigning unique identities to each of the containers. Sometimes if we want to do the container boundaries, and it also depends on how your data flows and sensitivities. It can be cluster level, node level, port, namespace level. These are not all. Sometimes it's n. So you need to make decisions on how you're gonna set the trust boundaries for your architecture. Yes, I think we are going into the next.
Yeah, sure guys. So now we move to the practical part of our talk. How do we actually organize threat modeling session? Because I work as a security consultant and most of my clients are in banking or insurance industries. And I can tell you how traditional threat modeling session goes there because they're obliged to do it for compliance reasons. So step one, way too many people on a meeting who have no clue about the app. Step two, people start muting microphones. Step three, switching off cameras. And in the end, only a couple of people left whose boss is asking them about threat modeling and no one else cares. So if we really want to organize it effectively, it's very difficult to people to brainstorm out of the blue because you work with your application every single day. You try to make it secure by design and then suddenly brainstorm and come up with brilliant threat idea is simply impossible. So I suggest always to my client to start slow and first of all pick collaboration tool. It can be a whiteboard, it can be mirror board, anything you prefer, and start with a good architecture diagram for your application. So there are no rules here. Basically it should be understandable for all of your team members, but these are kind of tips and tricks what is necessary to put on your architecture diagram. So people love colors, so start with colors, start with trust boundary marking, make sure to put tenant isolation, your network security segmentation, and your internet exposed interfaces at the highest point of area of attack. Make sure to include all these essentials you see on the slide. And the separate block is a data flow. Some people prefer to keep it on their actual architecture diagram. Some prefer to put it in a separate table. But there, the essential part is to mark a direction of a flow, especially where there is a cross of trust boundary. So this is to begin with. And now some handy tools which I can recommend from my experience. So first of all, there are some free AI tools called Threat Canvas and Devici. You can check them out even now. So they support importing diagrams in multiple formats. And also, especially Devici, it supports a layered approach. So you can organize your diagram as a canvas with multiple layers. And I usually suggest doing network layer, identity, and security monitoring layer, so it's not too crowded, but understandable for your team. And the second very cool tool is Erase AI. You can generate architecture diagram using it, and actually for this talk I use this tool. And also it has some free templates for Kubernetes architectures, very handy, especially when you need to come up with something very quick. And last thing, we are not trying to invent the wheel here, so try to adapt a Stride methodology, which is a well-known Microsoft framework for threat modeling. Just even Microsoft said that this kind of framework it should be adapted for cloud environments. So try to focus on spoofing, information disclosure, and elevation of privilege threats via cross-tenant identity and API leakage. So this will be your focus. Yeah, let's go a bit more technical. So what Emma mentioned regarding block decomposition approach, usually this kind of application which are based on microservices, which are cross-tenant, cloud native, they're very difficult to digest at one piece. It's very difficult for the team to threat model it all at once. That's why I try to suggest this block decomposition approach where we can split a complicated app into like tangible blocks, and then it's going to be more effective. So I'm going to show it on a practical example. So this is example of identity governance cross-tenant tool. So it is designed to support user lifecycle management from onboarding to access revocation and everything what happens in between. And like the industry application example can be when one company acquires another company and they need to stay in separate cloud tenants, or when a hospital, for example, for compliance, for regional compliance, they need to stay separate. Let's look further for this architecture. So on the left, you can see our tenant A, our managing cloud tenant. So basically it hosts all the main orchestration, user interface, and it is responsible for our user onboarding, provisioning, lifecycle. Of course, all the magic is happening inside Kubernetes cluster, which is our core orchestration and execution layer for the platform. And here, each business function is operating as a distinct microservice. So for user provisioning, one service; for access revocation, another. For the ease of understanding, I only put 2, but in real world, of course, there are more. And on the left, our receiving tenant or target tenant, which receives delegated operations and access policies from tenant A. So here it has exposed API for user account synchronization. It validates and enforces cross-tenant policies. It manages local data store. And of course, to operate the whole machine, we need a cross-tenant integration component here. I built it based on Azure Lighthouse service, but of course, many other cloud providers, they support similar services. So this service is for delegated management across tenants with granular role-based access control, which basically makes everything work. So, for threat modeling, I suggest to split it into 4 blocks. So for each of the blocks, I have defined, based on Stride, most critical threat categories. Of course, it doesn't mean that other threats are not applicable to them, but this is just the highlight, what is usually missed. So let's go deeper. The first block will be dedicated to internet-facing gateway. And what traditional threat modeling may miss here, and when I say traditional, I mean Stride framework, OWASP framework, LinkedIn framework, stuff like this. So they all treat internet-facing components as a single entry point with static perimeter control, and it usually fails to capture the dynamic tenant routing complexity. That's why here, when you threat model this type of your application, focus on spoofing and information disclosure attacks, especially cross-tenant identity impersonation and DNS cache poisoning. So this is going to be your focus. When moving to the cross-tenant service mesh, meaning your Kubernetes cluster, your microservices, here traditional threat modeling, they don't have much example of threats. Also, they treat all your internal communication as trusted and a single hop, which is of course not correct in the real-world scenario, and also they fail to capture pod-to-pod communication threats. So here you should focus on service account impersonation, MTLS certificate theft, and pod memory exposure due to side channel attacks to your shared Kubernetes node. Next thing is for your cross-tenant identities and API management. So here again, it's everything related to tenant-to-tenant communication. Of course, your API management gateway shouldn't be treated as like a simple gateway because it includes some cross-tenant delegation patterns, dynamic service principal relation, and stuff like this. And here I can give you example of a real-world incident like Storm 0558, where attackers stole a Microsoft sign-in key used for authentication, and actually they used this key to forge authentication tokens to access emails across multiple tenants. And of course, it showed us that Microsoft, unfortunately, didn't properly restrict which tenant could trust which keys. But also we can see, due to this attack, how compromise of one key can lead to data exposure in multiple tenants. And last but not least, all your data and storage components. Here again, your focus primarily should be on encryption violation, in transit, and database schema manipulation attacks. So this is usually the main problem with this kind of components. So I know it's a lot, but the main message I want to leave you after this block is that traditional threat modeling, it gives you false confidence in cross-tenant environments. And this block decomposition approach with stride mapping, it reveals more real attack surface scenarios. And of course, you should always double check it with some real-world attacks like Storm. Okay, let's jump to risk evaluation part.
Yeah, I'm going to introduce the threats. Some of you might have heard about this framework, to be honest. Threats, comparing to the traditional, the approach like likelihood and impact, is that it further divide further divide the likelihood and impact into different factors. So in this case, we have reproducibility. How easy can the threats be reproduced? And exploitability, how easy can it be exploited? And discoverability, how easy is it to discover the threat? So those three factors can be added together, and the average of that score gives you the likelihood of the risk. And on the impact side is that we have a damage potential, is how much damage can it be done, and the affected users. So how many users can be affected? The average of those two scores would be your impact. Now let me show you the heat map. So the heat map grid can be done on the whiteboard, something like a Miro. It's a tool that, a whiteboard tool that you can use to draw up your heat map. So this helps you to map out the risk in the low level. So when you assess the threat, the score can be in the range of 1 to 6. So for each of the threats, we need to provide a justification on how to clarify how likelihood and impact scores were derived from the threat factors. This is an example that I use threats to calculate one of our threats. So the threat is compromise Kubernetes service account, impersonate legitimate microservices to access cross-tenant data. So for example, the damage potential can be high if we are able to successfully demonstrate this attack. Because we are accessing cross-tenant data, so the impact could be quite high. And the affected users, depending on what's the context. In this case, if we are talking about multiple tenants, that probably means that that tenant is going to serve different tenants as well. So that could potentially affecting different customers in this case. So the likelihood and the impact is calculated at the bottom of the table. As you can see, that as a result, in this example, the risk level is high. So manage your threats can be done in multiple different ways. If you are familiarizing with ticketing systems like Jira, you can use that. And also if your team is using some backlog systems, then you can also use that to log your security tickets for threats. So each of the threats needs to be logged as a security ticket, and you need to give them the priorities depending on the risk level that we defined in the previous page. Yeah, so this page, I want to just briefly cover when is the best time to do like a threat modeling sessions. So the initial threat modeling session, the full threat modeling sessions should be done at the beginning of the new project, right? Yeah, so when you are working on the HLD, the high-level design, high-level architectural design, that's when you need to do the threat modeling. So, however, you also need to also have security controls already designed into that high-level architecture to give you a more accurate results for threat modeling. And another thing is that we like to propose that during the course of developing your application, you also need to do some ad hoc sessions to cover those changes, or if you are adding new features and functionalities. And an annual review needs to be done for that as well. So the key message for this one is that I would like to highlight and emphasize that the initial threat modeling session needs to be conducted after the initial system architecture design, and also needs to be complete before the detailed design. So when you basically, if you have the concept of high-level design and lower-level design, it should be done between the HLD and the LD documentation. Yeah. So what are the triggers for ad hoc if you don't have any idea about when should we do the threat modeling sessions? Then these are the factors that you can assess whether there is a new threat modeling session needs to be done. So probably the most important one that I would like to call out is anything that changes to the architecture needs to be done and requires a new threat modeling session. Okay, so talking about scaling the threat modeling, one of the approach is the threat modeling code, threat modeling as code. So if your company is embracing infrastructure as code best practices, then this is going to be handy for you. So basically, this process is codified, version control, automatic, and integrated into your CI/CD pipeline. So you can use the practice of configuration as code to be embedded into your process for software development lifecycle. So the approach is that you need to define the resources, architectural components, and data flows, and trust zones, and boundaries in a declarative format. So for example, you can use Terraform, and you can define your code in the YAML or a JSON file. So those files can then be shared, can then be stored and managed in a centralized repo where you can trace the changes to the code. So the key thing or the magic in this process is that you need to integrate this into your security gate. Yeah, you need to integrate it into the CI/CD pipelines where you trigger the security gate. However, I do need to warn you that there are a lot of challenges with this approach. To make it more practical is really hard because automating the threat modeling as code approach in the pipeline can slow down your deployment sometimes because so basically a careful design of the security gate needs to be done for that. Okay. Yeah, so on this page, so I'd like to also introduce who should you engage with in the threat modeling process. So some people are probably going to think about developer and security team. So that's the two groups of people that is needed in the threat modeling process. But actually, we need to engage with more people. For example, the PM and the business analysts, architects, and everyone in the project team needs to be in that threat modeling process. So in an agile situation, like if your company is embracing agile process, then this kind of approach comes handy. So basically, at each of the sprints, you can do initial threat modeling at the beginning of the project phase, and then you can do a sprint-based threat modeling at each of the sprints. Yeah. So for example, in one sprint, if you are adding on a design for a microservices or feature, then you need to threat model that separately because a feature might be connecting to a new API endpoint or cross API endpoints, depending on what the situation is. So a new threat modeling needs to be done at that point. Right. So this is we are going into the AI-assisted threat model, and we'll be providing a demo.
Yeah, so quick, fun AI part. I tried a bunch of AI tools that specifically for threat modeling, and here are the things that these tools do exceptionally well. So of course they can do automated threat pattern recognition because they support catalogs using frameworks like Stride, like OWASP, like Mitre Attack, especially the tool Devici I mentioned before. It's very cool in this, and of course it helps to address like the traditional problem where security team supports on average more than 50 applications, which is very big workload, and you don't have hands to do the threat model. Of course, it shifts security left because you can deep dive into threat modeling without deep understanding of security. And if your architecture documentation is a mess, it can help to aggregate it pretty well. But of course, there are three like critical pitfalls for AI-assisted threat modeling. Of course, first is generic threat trap, because they generate you extensive list of common textbook threats, but they don't reflect like the unique attack surface for cross-tenant microservices applications. This is because they are trained on some traditional monolithic frameworks. Next critical thing, they ignore existing mitigation, especially your cloud native. So when you're doing threat modeling using AI tools, make sure to include it into the context, because the AI tool assumes you have nothing yet. And third thing is, of course, they misunderstand cross-tenant complexity completely. But here the tips how to make it actually work better. Like use the block decomposition approach I showed you before. Provide as many contexts as possible, especially explicitly describe your tenant isolation boundaries, your service mesh, your cloud native controls, and the most important model provider choice matters. So try to choose models which support reasoning tokens. So reasoning tokens are like input-output tokens, just 6 times more expensive. So what they do is they allow your AI tool to actually build a chain of thought. So AI will check like, okay, does any path actually cross a tenant boundary without mutual TLS before giving you, some generic threat list. So here on the slide are models which support this kind of tokens. Quick demo, very quick. Let me just switch. So here is the open source tool. It's called Stride GPT. It supports multiple model providers. For this demo, I used Google AI, and for the model, I used Gemini 2.5 Flash, not Pro for cost optimization. So here I dropped the diagram of our identity and governance platform you saw before, and the prompt is just description of this solution. And then I asked the tool to generate me threats. I will a bit scroll down so we don't wait. So as you can see, it provides quite some good threats. Also, it identified very well components and how they work with each other. But the threat list is very short, is a bit chaotic, like it jumps from front door, then it jumps to Kubernetes cluster, to Cosmos DB, so it's a bit unstructured, and using it as is for threat modeling with your team is not that great. That's why for the second prompt, wait. How can I go back? Sorry, guys. Okay, so video got stuck, but for the second thing, I used the same kind of prompt, but I asked this tool to generate threats only for our service mesh component. Now it should work. Yeah, so let me show you. So here I asked the tool to take into account full diagram of the solution, but concentrate only on service mesh and AKS cluster. And I also told about the trust boundary, stuff like this. And then when we see the output is much better because the tool started analyzing all kinds of straight categories, but particularly for Kubernetes, so it was analyzing it from different sides, and this kind of output can be used, you know, as a starting point for your team, because they don't need to invent threads out of nowhere. This can be a good baseline. And last thing about this tool, it's very cool because when you do your prompt, you are likely to miss something, and here it gives you improvement suggestion, how can you make your prompt better for threat modeling. Yeah. Okay, let's move to final remarks for our talk.
Yeah, just gonna wrap up this talk. So what we want to tell everybody is that threat modeling is not just just a box to check, or it's not just drawing a line. It's it's an engineering discipline that needs to shape the future of how we build everything in the cloud. So yeah, it's not just specific to application or cloud native. It's also very important to threat model your cloud architecture. So what is the future of cloud threat modeling? So we already see that ChatGPT or whatever, AI tools like LLMs can be used to automate threat identification and analyze your architecture diagrams, code and configuration. And the second trend that we have seen is a lot of CSPN2, cloud security posture management tools, now have integrated threat modeling process within their tools. So for example, even Microsoft Defender for Cloud, they are starting to map out the cloud assets and configurations. And attack path, that is a good tools to use to kind of identify what are the threats in your landscape. And also, Sensor tool can also be used to generate the data flows to provide more visibility into your cloud footprint. Yeah, so that's everything that we've got here, and I hope that you enjoyed the talk today. And if you like, you can connect with us. Thank you.
Thank you.
I believe, do we have any questions? No, okay. Okay, we will be sticking around, so if you have any questions, just come to us. Thank you.
Thank you.